For 3.1, we're reviewing degrees, angle rotations, and we're introducing another angle measurement called radians. So the first thing we want to go over is our quadrants. Okay, so this is quadrant 1, 2, 3, and 4. Okay, so when we do an angle rotation, quadrant 1 starts at 0 degrees over here and goes all the way to 90. So then quadrant 2 is 90 to 180. Quadrant 3 is 180 to 270. And then quadrant 4 is 270 back to 360 degrees. So that means that one full rotation equals 360 degrees. Another way that we can measure angles is in radians. So one full rotation also equals 2 pi radians. So that means 360 degrees equals 2 pi radians. Okay, so 90 degrees is the same thing as pi over 2. 180 degrees is pi. And 270 is 3 pi over 2. We can convert from degrees to radians using a simple calculation. Okay, so if we begin with a degree, we can multiply the degree by pi over 180. Okay, and this will give us a radian measure. Okay, if we start with a radian, we can multiply the radians by 180 over pi, and that will equal a degree measure. Okay, so 15 degrees, I'm going to multiply by pi over 180. Okay, across the top, across the bottom, and make sure that you fully simplify. That would give us pi over 12 radians. Okay, example 2. If there's a pi in the original, then I know that that is a radian. So I'm going to turn it into a degree. So I'm going to multiply by 180 over pi. That gives us 480 degrees. So you can cross cancel the pi and then just multiply the fractions, use your calculator, and have it simplify. Okay. So the last one, okay, even though it is a negative degree, we're going to talk about that in a couple minutes. We're going to keep the sign. It's a degree. So again, I'm going to multiply by pi over 180. And this is going to get me negative 49 pi over 36. Okay, so that's our first type of problem here. Our second type of problem is drawing an angle rotation and determining which quadrant the terminal side is going to end up in. So let's first talk about that. Okay, when you draw angle rotations, okay, we always start on the positive x-axis Okay, to draw a positive angle, we're going to go counterclockwise. Okay, and to draw a negative angle, we're going to go clockwise. Okay, so you take your angle measurement. Okay, I like to work in degrees, so if it's given to you as a radian, you're going to want to convert first. Okay, so my first angle here, 1,574 degrees, is very clearly over 360 degrees, which is one rotation. So you want to dial backwards by subtracting 360 off of that to determine how many full rotations you have, okay, to try and figure out where your terminal side is going to lie. So if I subtract 360 from this, I can do it 4 times. So there's 4 full rotations in this angle. After I do that, I'm left with 134 degrees. So 134 degrees is the angle that I want to use to determine where my terminal side is going to end. Okay, so the terminal side is just where does the angle stop. So 134 degrees, okay, so if I start on the positive x-axis, okay, 0 to 90 is the first quadrant. My angle is over 90, but it is less than 180, which is over here. Okay. So putting in that line without an arrow, that's my terminal side. Okay, the curved line with the arrow, that's indicating my angle rotation. So 1,574 degrees would be in quadrant 2. Okay. Now my second angle, negative 5 pi over 6, I want to first turn this into a degree. So I'm going to multiply by 180 over pi. I'm going to get negative 150 degrees. Okay, so if I map out my angle rotation, I start here. Negative, I'm going to have to go clockwise. Okay, so this first quadrant, really quadrant 4, is 90 degrees. I'm going to need more than that, but less than the 180 degrees that I would get over here. So my terminal side is going to be in quadrant 3. Okay, so at this point I want you to pause the video and try and do the angles for number 6 and 7. Okay, so you should be getting 6 is in quadrant 4 and 7 is in quadrant 2. Okay, our next skill is finding a coterminal angle, one that is positive and one that is negative. So we're just going to be adding and subtracting 360 to the given angle until we get something that is equivalent, positive and negative. So coterminal, if I have an angle rotation, and let's say that it has a terminal side in quadrant 2. Okay. Coterminal means I can do any number of rotations and my angle will still come back and end at that same terminal side. Okay. So really the angles are equal, they just, one may have more rotations in it than another. Okay, so if we start with 380 degrees, in order to get a positive angle, you could take 380 and you could add 360 degrees to it. So 380 plus 360, we could say that 740 degrees is a positive angle. Now, because 380 is over a full rotation, I could also subtract 360 degrees and have a coterminal angle of 20 that still counts as being a positively measured angle. Now, in order to get a negative one, I need an actual negative number. So I would subtract 360, okay? And we know that that brings me to 20, but that does not count as a negative angle. So I would have to subtract 360 again. So really, my negative angle here would be negative 340 degrees. Now, sometimes you'll be asked to write an expression that represents all coterminal angles. Okay, so in order to do that, we would simply take our angle measure, which is 380 degrees, and we would add 360n. Okay, so the 360n is representing any number of full rotations because 360 degrees is a full rotation. Okay, and then we're going to indicate where n is an integer. Okay, so now let's try an example that is in radians. So instead of adding 360 degrees, we're going to add the equivalent to that, which is 2 pi. Okay, so if I take negative 5 pi over 9, and I add 2 pi to that, so you really can kind of just ignore the pi's for a second. Okay, and you're really just adding together the fractions. So negative 5 over 9 plus a whole number of 2, okay, it would be 13 pi over 9. So that would be a positive angle. For a negative, okay, even though this is already negative, we're going to subtract 2 pi. Okay, and we would get negative 23 pi over 9. Okay, our expression for this one would work the same exact way. So we would take our angle measure, okay, and then now we would add 2 pi n, okay, because the 2 pi represents the full rotation for radians, right, where n is an integer.